I think it's time to switch back to some digital electronics. So what I have here is a very old static RAM chip. I have it in the breadboard here already. This is a Synertec SY2112A. And if I'm understanding the date code correctly, it should mean that it's from the 26th week of about 1984. So this is a pretty old chip. I've had this chip a very long time. I think it was definitely old then. I probably got it, I don't know, almost 20 years ago, but the chip is, I guess, 40 years old now at this point, which is a little bit distressing. I'm sad to say I'm actually still older than this chip, but not by much. All right, so I thought today might be fun to hook this up and just try to store some values in it and read them out. I've never, I know the theory of how that works, of course, for a RAM chip, but I've never done it. So since I have this ancient RAM chip here from my old stash, I figured I would just try it. I mean, why not, right? I'm hoping I can just hook up a dip switch to it for the address and maybe another one for the data bits that I want to program into it, and then maybe some LEDs to show the current results when I'm in read mode, something like that. I don't know for sure if that will work, to be honest. I have only looked up the datasheet. I have not really studied it. It's 256 by 4 static random access memory, SY2112 from Synertec. This is static random access memory, so static RAM, and that differs from dynamic RAM, which has to be refreshed constantly to keep its values in memory. Static RAM doesn't have that problem, you could say, but I think the trade-off is that static memory is usually maybe more expensive and also slower. I don't 100% know if that's always the trade-off. It probably depends on what era you're talking about. But the benefit of the static, of course, is I don't have to worry about refreshing it. In theory, at least my understanding of it at the moment, is I should be able to write bits to an address, and then they'll stay there for as long as this thing has power. Okay, so looking at the pinout here, since you can only store 256 words in it, and each of the words are only 4-bit, you don't need a ton of I/O lines, for both addresses and for data, right? The values you can store in this thing are not that big, and the number of them aren't too big either. So it looks to me like this has 8 address lines, so A0 through A7, and then it has 4 input-output lines, which I'm assuming, that's the data bus, right? Depending on how you toggle the read-write switch determines whether these read or write. And then there's another one here called CE, which I know stands for chip enable. So I'm fairly sure that when that is, because that's active low, so when this is high, basically everything, all the inputs on the chip are just ignored. And that exists in part because often on a circuit, a computer circuit or something, you're going to have a bunch of things needing to talk to RAM at different times or in different configurations, and that can turn the RAM on and off. So like if you want to talk to another device on the bus and not the RAM, you would tell the RAM to, stop listening, right? You would deactivate the RAM and then activate the thing that you're trying to communicate with that's on the bus, maybe a serial port or, something else like a input-output card or something. So for my purposes, what I want to do is just hook up, real basic, just a switch on here, try to address it, and see if we can store some data. And I have no idea if this will work. This chip is really old. As I said before, I've had it, in a baggie that alternately lived under my bed, in a dresser, on the top shelf of a closet, and in the garage over the many years that I've had it. So it might be a minor miracle if this even works. All right, for hooking it up, I think I will use this 8-position dip switch for my addresses. And then I'll need a size 4 switch. There we go, if I can get it out. Size 4 switch for the data input. And according to the data sheet, VCC is on pin 16 and ground is on 8. So I'm trying to figure out what to do with the switches here. The address line inputs are mostly on this side. And for example, A0 is on pin 4. 1, 2, 3, 4. That's this one. So I figured it'd make sense to keep it on this side and connect it off to the switch's position 1. But right now that switch is off. So I suspect that means that this side should be tied low. When I turn it on, we need it to be pulled high. I guess I would put a 10K on the other side of all these switches to pull it up to high when the switch is on. I think that'll work. Okay, I think I have all the address lines connected from the switch to the chip, and now I want to tie all of them to low so that when the switch is off, the address lines are low, because that makes sense. Okay, all the switches are now tied low so that when they're off, this signal going into the address lines is low, which corresponds to binary 0. And then I will put 10Ks on the other side so that when the switch is on, it's being pulled up to high, because the connection should then go from high through the resistor, through the switch, through the wire to the address line. 10K resistors all along the top end of the switch. So when I turn one on, it should mean that that address line is pulled high. Chip enable on the data sheet here is marked as active low, and that's pin 13. So I'm going to pull it low because I'm just always going to be playing with this. I'm not doing anything fancy. So I'll just pull that low permanently. And then what I think I will do for the read-write pin on 14 is I'll just put a jumper that I can easily move back and forth when I'm testing stuff. So that is, it just says read-write. I'm assuming write is high, but actually I guess I don't know that. Where does it say? Okay, down here on the timing cycle for like a write cycle, the read-write pin looks like they're saying it has to go low for a write. And up here on the read cycle, it's weirdly enough, why don't they have the read-write pin at all up here? I'm not actually sure I understand that. I mean, I guess you're just supposed to assume it's the opposite. I think this means that writing is active low. Well, I guess we'll just have to try it and find out. I mean, it's not going to be that hard to test. Boop. So the only thing that I don't have hooked up are the I/O pins, which I do eventually want to hook here, but I'm thinking about trying something. I think I'm just going to hook up the power right now, and I'm going to get out my handy dandy logic probe, which I've almost never used, and I assume that the data will have garbage on it, but maybe if I'm lucky, I can change the addressing and sort of see the data on the logic probe. I don't know. I think that works. In theory, I think if there's garbage in there, maybe it'll change. Of course, I might get unlucky and it'll initialize to the same garbage value everywhere, but we'll see. Okay, so right now we should have an address of all zeros in here. In theory, it's in read mode. So let's see what the bits are. The input-output bits are the last 4 pins on this side, I believe. Let me check the data sheet. Yes, the I/O pins are 9, 10, 11, and 12, and they're in order, which is nice. We have low, high, high, and high. So if we flip this back, low, high, high, high. Can't remember if that's what it was before. Low, high, high, high. So far they're all the same. Or, I mean, I could have something totally connected wrong here. I might still be misunderstanding something important. Let's try a different strategy. I think I'm just going to hook up the LEDs to my input-output pins. How is that going to work, though? This is the part that actually, when I was thinking about doing this video in the first place, it occurs to me, I think maybe there's a piece of information I don't know, because if I hook LEDs up to the output pins, they're going to be there even when it comes time to want to do the programming, right? The setting of their values. I guess that might not matter. I'm just going to hook them up. Why not? There's no point sitting here wondering about it. I can just do it. Okay, I have them all hooked up from the I/O lines to the LEDs. So changing the addresses, I'm getting no effect whatsoever. So either they're somehow all initialized with the same garbage value, or I've got this very wrong. Let's try switching the read-write pin the other direction. So now it's being held low. Now my understanding is that should be a write. If that's correct, I feel like since these apparently aren't on right now, did I just write 0 to the first position? If I switch it back, there is a 0 there now. But there appears to be a 0 everywhere else as well. It's possible I just killed something because now nothing is lighting up. It's interesting that every time I turn it off and on, it resets to the same value. Well, I better check my assumption here about how the switches are working and make sure that this pulling high stuff is actually switching it from a high to low signal.
A few moments later.
Wait a second. I think I have a fundamentally flawed... I think I connected this up incorrectly. I don't know how I messed this up, but I can't hook it up this way. The short circuit here is always going to be preferred, right? This is completely wrong. Assuming I published this in the first place, I'm sure many of you are screaming at the screen right now the whole time, because this is pulled directly to ground down here. This is always going to win. It's less resistance here than, you know, just because I flipped the switch here, that's not going to work. I think the solution is I'm going to flip the switch upside down. Something's off here too. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, okay. I've been confusing myself since the start here. I have 8 resistors, but I have 9 jumpers here pulling to ground. I was off by 1 there, and I was off by 1 over here because I noticed one of the address pins wasn't actually connected. So there are a lot of things wrong here. I guess I basically am going to have to start over. Okay, that's promising. All right, good. Changing the address is getting us different values, so that part is actually working now. Awesome. So what we're doing here is we're putting an address into the chip and reading what value it has at that memory location. And it can only store 4 bits per address. And right now it's just initialized to garbage. The thing that in my mind that I'm not sure about yet is, like, if I wire these up correctly to the input-output lines, then they're always connected. But obviously sometimes I'm going to be reading and sometimes I'm going to be writing. That's got to be a problem. If I just connect these up, even with the correct, you know, pull-up resistors on here and sort that out, this is always connected. So if I say, you know, 1001 on here and switch it to write mode, I think it would write correctly. But when I switch it to read mode, I'm putting a 1001 on there at all times, you know, because this is hard-coded. This is hardwired to always be that, right? Even if I turn them off, then I'm putting a 0000 on the bus. So that seems bad because you would never be able to read or write if multiple things are on the same data lines trying to do stuff, right? Hence, I mean, I think that's what a bus conflict actually is and what it means. You have multiple pieces colliding on the same bus because the bus can only be used for one thing at a time. So I think in order to do this, I would have to program it and like physically remove stuff so that it doesn't interfere when I switch back to read mode. Now, I think there is a chip that does this sort of thing, and I think it's called a bus transceiver, and I'm pretty sure I actually have one in my TTL kit, and perhaps I should just get that out and hook it up. Maybe that's the thing to do. Okay, I have an SN74LS5245N, which is an octal bus transceiver, and if I'm understanding this correctly, this thing lets you connect 2 buses to each other, an A bus and a B bus, or disconnect them if you turn off the enable pin. I don't have the exact sheet for this particular manufacturer, but there's a Texas Instruments sheet, and it appears that you can also change the direction, so you could read and write through this thing. For my purposes, I'm only going to write, so I think I will tie that to a particular value. And of course, this has too many pins on it. It's for an 8-bit bus. I'm only dealing with 4 bits here, so I don't need to hook up a bunch of them. So I think I'm going to put it where I had my switch and move my switch over here probably. And I'm going to have a whole mess of wires, but at least I only need to do 4 over there. So I'll have to hook up power to this and then connect them over. So I think, if I'm understanding correctly, I would hook my switch up to bus A, and then I'll hook bus B from this chip up to my RAM chip. And then I'll have to double check the direction and tie that in the direction I want it. And then we have the chip enable pin on the transceiver itself. When that's disabled, it's as if I've unplugged the switch. So at that point, it should be safe for reading from the memory. When I want to write, I'll have to enable the bus and the write mode at the same time on the memory chip. And so when they're both set up, then it should take the values from my switch through the transceiver into the RAM and save a value. That's my theory. I hope this works. Okay, here we go. All right. So we should be in read mode. The bus transceiver should be disabled, which means when I change these, we should be getting different, and already we're seeing different garbage values in the memory. So we're at position 0 right now, and we have 1 0 0 0 in there. So let's say we want to change that. So I think what I do is I put both of these jumpers low. That activates the bus transceiver and recording mode, writing mode. And right now, okay, something seems to be somewhat backwards here from how I was thinking about it. Now they're turning on and off. So somehow the logic is inverted here from what I was thinking. Well, let's just ignore that and we'll see what happens. So right now we have this set in here. Writing is enabled. So I think that means we have now written to the first location in memory, 0 0 0 0 0 0 0. Okay, so if I switch this back to read mode and then disable the transceiver, we still have the same value in there. So I should be able to change this. Yep, this has no bearing on the output anymore because it's now disconnected from the data bus. But if I go to the next memory address, we have something else in there and something else, the garbage or whatever that was in there before. Okay, I think that worked. So, okay, let's just flip this. Now we're going to try writing this pattern into the next memory location. So to do that, we'll switch to write mode and switch our bus. And that should be all it takes. So now this should be written into the second memory location. So if we disable, we go switch into read mode, disable our transceiver, and it's still the same, which is excellent. And we should get, and there we have the original value that we had in position 0 and in position 1. Okay, that's really cool. Okay, so this is basically correct, except that I have that issue where the logic values over here seem to be inverted somehow. So if I flip into write mode, and so now what we have is the data input is tied through the transceiver onto my data bus, and it's now the active thing, and that's what we're seeing here. So it's clearly flipped around. I'm going to have to trace this wiring and see if I can see anything obvious here, or see if I can understand where I flipped it.
A few minutes later.
I think I see the problem. And again, it's another kind of really dumb mistake. This is on, so this is high, right? And if you follow this all the way through, it remains high all the way till it gets to the RAM chip, and they're all the correct bits. This light is in fact connected to that line, that chip line. So the issue is, though, is that this is high. This side of the LED is high. So high and high, no current's going to flow. Basically, these things are flipped around. So like a lot of the other stuff that I've connected, I'm just having like a backwards day today where I'm connecting everything the wrong way around. The problem is actually the LED display. So all I really need to do is flip these around. Okay, there. I think things are the way they're supposed to be now. It's currently in write mode, and I have a 1 over here, and that's what I see. So these things now line up, as we can see. So that's good. Since we're in write mode, I believe we just wrote all 1s to the first position, and probably the second position, and the third position, and now the fourth position in memory. So if we switch back to read mode and disable the transceiver, so if we go to a new position, we're getting different values because garbage. But the first position has, the first several positions have all 1s because that's what we programmed into them. So now if in the second position we wanted to store this value, we would enable that, enable write, and then that's all you have to do. It should be stored now. Disable that, go back to read mode, and now we don't see anything. I don't know what happened now. Now I'm not sure what happened. This was working and now it's not suddenly. Oh, I think I know what I'm doing. I can't turn off the transceiver before I switch to read mode because then it writes the absence of signals to the RAM. So I can't do that. I think I was just overwriting what I had just written. So what I need to do is I need to switch to read mode first and then disable the bus transceiver. That way it kept the value, right? Okay, that makes sense. Okay, well, that was interesting. Ran into quite a few unexpected problems. A lot of them were my own fault, connecting things the wrong way. When I sat down to make this, I did not anticipate having to use this bus transceiver. I knew there was something in the back of my head that was going to come up, and I couldn't quite put my finger on it. And so that led to a lot of procrastinating and being unsure if I even wanted to start recording a video because I just felt that I was missing something. But of course, without sitting down and doing it, you know, you really don't, sometimes it's hard to know exactly what you're missing until you really sit down and do it. And of course, when you're on the sidelines just watching, a lot of times things can seem really obvious. But I mean, everyone should know that, you know, that's just how life is, right? When you're busy doing stuff, you're focusing on one thing or a certain thought in your mind, and it can block other thoughts. You know, that's the thing that makes stuff difficult to learn sometimes, and makes it difficult to experiment even sometimes because you get stuck. You get stuck on the wrong path. All right, so I mean, that's kind of in line with what I want to mention. My videos here aren't meant to be educational in the sense that you come here to learn how to do a thing necessarily. I mean, obviously, I wouldn't mind that as a side effect, but that's not really the intent. My intent is just to do it and to show the process of learning in an effort to maybe help others get started, I guess, you know, or even just get started myself. I mean, quite honestly, if it wasn't for trying to make videos of some of this stuff, I would have forever sat on the easy chair thinking about how it's probably not that hard and then assuming I knew how to do it until you sit down and actually do it. You know, it's all theoretical, right? And so what I'm kind of trying to do here is not so much teach it. I'm not trying to be an expert. And, you know, I've said this before, but I'm in no way an expert on this. I mean, that should be quite obvious. So it's just about the exploration and the learning of it. And of course, you have to start somewhere. There's so many people, essentially, they learn in secret. When you're on your own and just wanting to experiment, sometimes it seems like the rest of the world already knows how to do everything. And I'm trying to put out the message that that is just not the case. You can always just jump in and try stuff and mess around and go for it, you know. So anyway, if you like this sort of thing, please subscribe, thumbs up. And if you don't, I guess you should have stopped watching a while ago. And that's it for now. And maybe I'll see you next time. Bye.